Hello everybody, I'm going to put together a video here on a new purchase of mine, which is a Harbor Freight Tool Grinder made by Central Machinery. Now these actually aren't bad. They'll list on their website for $189. They had a local sale in my area for $153, and I had a 20% off coupon, so I actually picked this up for $134 and change out the door, which I thought was a fair price. Now, if you're not familiar with these out of the box, they need some work. Primarily the tables, when you try to adjust the tables, they do not want to operate. So this is going to be kind of a documentary on how it was, what I did to make it better, and the end result. Now this, I just got it out of the box a couple days ago and haven't really done anything with it other than put it on. As you can see, a lot of the tables and the water trays are removed. Main reasons is I'm currently working on it, and I wanted to let you guys know what you can do simply to make the tables work better so you can actually adjust them without a lot of hassle. The main problem on the tables being the trunnions, and we'll get to that in a minute. I have not dressed these wheels, which the wheels are pretty much garbage. They will work, but you'll spend a lot of time working on them. So just to see how it runs, I'm just going to reach up here and flick it on. It does take a couple seconds to run up to speed, and it'll go through a little bit of a vibration, but once it gets up to speed, it actually runs fairly well. So here we go. And you heard that right at the end. Don't know if you did, but it was there. So it's got a little bit of vibration. The wheels have not been dressed, so there's some run out in them, as well as the back plates that the wheels are actually mounted to. You can see the aluminum rim here as it's spinning down. I need to watch my fingers. That I will eventually take these back plates off of the grinder, mount them up on my South Bend 9-inch lathe, and I'll true the front surface. Now I will do that, but I will index them on where they are in relationship to the spindle, so I can make sure and get them back in the right orientation. And providing there's no spindle run out, the front surface of these should run true. Now this is a casting, maybe a die casting, or it could be a sand cast piece of aluminum, so the back of it has a lot of run out as well. I don't know if that's going to be an issue. If so, I may turn the back down. So I'll address that as it goes, maybe in a future video. Okay, on the work tables and the trunnions, for those of you who don't know, this is a trunnion. I'm going to discuss what I'm doing here. I already have one of them pretty much completed. This one I have not addressed yet. When I mounted the tables, I really wasn't able to adjust it. So what I ended up doing was taking it off to try to diagnose where the issue was. And if you will take one of the trunnions, which they should be bolted out of the box, I believe, and go ahead and tighten it up just to make sure everything is locked in place. And if you'll actually tilt the table up to this type of a view and put your straight edge on the bottom of it, not your straight edge, rather your square. If you come up to here, I don't know if you can see this, but I have a large gap on the bottom of maybe 20 thousandths. It's quite significant. It was identical on the other side. So in this casting, this is actually not quite at a right angle. Now, one of the things that can also cause a canting like that is this particular flat here, where the trunnion actually sits, could be different from side to side. Now, I didn't really measure these, because what I did in the second pass was to actually just take one of the trunnions as it was and look across it with a square. And there's definitely a cant here that is, in this case, it's an acute angle. So when this is actually mounted, it's giving me more space on the bottom than there is on the top. Now by doing that, if they're left as is, when you go to mount these, there are 2 guide pins on the sides of the grinding wheels. To get it loose enough to where you can actually adjust it, the guide pins are almost falling out and the table wants to fall down. So to address that, the first thing that I did was I just took a piece of wet and dry sandpaper, wetted it down, stuck it to the top of my granite surface plate, and just machined this by hand, just to flatten the imperfections here. Now this isn't perfect, you know, you don't have to take off much, you just need to mainly get it reduced down to where it's as flat within reason. And then I took a deburring tool, I went around all of the edges, I went ahead and came in and cleaned out the slots, like so, and called that operation good. Now from there, what I did was, you can see this surface here has been milled. I mounted it on my milling machine. I happen to have a horizontal little Atlas milling machine, so if you have a mill, vertical mill, horizontal mill, your setup and operation is going to be different depending on which one you have. So by simulating my mill table, I just used a 1/2 inch 3/4 end mill. I'm sorry, a 1/2 inch end mill to do it. I just let it hang over to the edge. I made 3 passes. Now to mount it in the mill, I just used a straight edge to work off of one side on all. The milling operation wasn't quite straight, doesn't really matter, is that they're all made the same when you put them on. Any variations here, you have a pin that adjusts a pointer so you can set your 0 to it. I don't rely on these graduations all that much anyway because they're not all that accurate. So once I faced that off, I came in and deburred the edges and then mounted it back up for a test. Now before I go to the test, just to kind of give you an idea, even though I'm not quite finished with it, one thing that I noticed on the tables is it has these driven in pins, and when I actually took a tool bit and simulated how I would actually be doing the grinding on the bit, as I was running across this area, there was actually little ridges and humps here. See, there's one right there. It does not want to slide off of that. So in my first test with the machine, I noticed that it was grabbing there and it was kind of bugging me. So to remedy that problem, simply all I did is, here's one of the drive pins. They're mounted in these holes. Brass punch and a hammer, knock them out. Once you get those knocked out, you can come in here, and I don't know if this will pick up on the camera, but I took a small half-round file and just cleaned up these corners to where now the bit will slide across it without catching on any burrs. You could also use a stone if you want, maybe a Dremel, anything you want, but it only took me a matter of a few minutes to file those out. Now all I have to do is drive these pins back in, reverse of the opposite procedure. Now when you're doing that, these are knurled pins. Before you just go hammering it in, put the pin in, register it to the grooves that are already there, and then drive it home and seat it with a punch, brass. So I'm going to stop the video for a minute. I'm going to put this table back together, and then I'm going to mount it up on the machine, show you how I actually adjust the table, and then how it operates. Now I don't have one put together that will show how they actually come out of the box, but try it. And once you put them together, you'll be doing this procedure real quickly. Now there's one other thing that I want to talk about before then, and that is the actual hardware to lock the tables. These actually come with a washer and a lock washer